Welcome back. Today we are going to finish up section 2.7. So today I'm going to teach you a slightly different way of approaching these absolute values. You can always find the vertex and make the table, but instead of making the table every time, what I'm going to teach you is how to manipulate the functions based on all those transformations we talked about in 2.6. So the way to do that, I'm still going to first identify the vertex. And the vertex we identify by the horizontal and vertical shifting. So if I'm looking for that vertex, well, remember, a, a negative means you're moving to the right, so positive means you're moving to the left. So our vertex is being shifted to the left 3, and then down 2. So that's where this vertex is going to lie, down at -3, -2. So that's still going to be the first point that I plot, and then I'm going to make my axis of symmetry. Now, once I have that, for these more complicated ones, instead of having to make a table for everything, you know that the absolute value function follows a line. So originally it'd always go up 1 over 1, up 1 over 1, just like a line that had a slope of 1. So I want you to consider this vertical stretch that we're seeing. That vertical stretch you can actually understand as the slope of the line, which you maybe saw in the previous notes. So let me show you. So when we did these examples with a 4 there, notice that that 4 ended up being our slope, up 4 over 1. For this one, we had a 1/3 stretch. So what happened? We had a slope of 1/3, up 1 over 3. Right here, we had a -4, down 4 over 1. So each of these have been giving us the slope all along. So instead of having to make the table, I can use that 4 as my slope. So what I mean by that is starting at that point, I can go up 4 and over 1 to find my next point. Now, don't forget that's not the only point that I'm getting. We get the mirror image. We need to get our V. So we also get its mirrored point over here. But now we can continue following that same slope, up 4 over 1, and get its mirrored point right over there. So without ever making the table, you can end up seeing exactly what you need to do. Finding the vertex and then using that vertical stretch to tell you what the slope is so you can find your points right away. So let's follow this one. So again, my first goal, I want to find my vertex. So I'm going to identify the horizontal and vertical shifting. Well, remember, a negative there means a shift to the right. So our x is shifting 3 to the right and 4 up. So we're going to start by finding that vertex. So over 3, up 4, there's my vertex, and I'm going to put in my line of symmetry. All right, so next step, I'm going to look at what is multiplying my absolute value, because that is going to give me the slope of this line. So I see a -2 there. So what that -2 means, slope of -2 means down 2 over 1. But that's not the only point I'm getting. I also have to mirror that point. Now, down 2 over 1 again, and I mirror that point. Down 2 over 1 again, and I mirror that point. So you can clearly see how solidly I'm getting that V shape, just like I was supposed to. Now, again, you can always double check your work by making the table. However, this is a nice quick way of showing you how to do it where you won't need that table anymore to graph these complicated ones. Now, this one is a little bit trickier, okay? So let's say you have something more complicated inside your absolute value than just the shift. What that means, what you need to do is you need to pull out whatever you can. So what I mean by that, 4x minus 12. Now, both of those are divisible by 4. So what I'm going to end up doing, I'm actually going to factor that 4 out. You can factor a constant out of an absolute value, okay? So, because of that, now I have the setup that I need where I can see what my horizontal shift is and my vertical shift. So, remember, a negative with the x means it's being shifted to the right 3, and that positive 6 means it's going up 6. So I'm going to plot that first. 3, 6 puts me right there. And I'm going to label my axis of symmetry. Next, I need to start plotting some points. So I identify that 4. That 4 is going to tell me what the slope of my lines are. Okay? Now, unfortunately, we're going to be going slightly off this graph, even with the first slope. So I'm just going to do the best I can, and we'll just have to work from there. So I start at my point. I have a slope of 4. So up 4, 1, 2, 3, 4, over 1. And we end up getting the mirror image of it as well. So over here. Now, because I'm already off my graph, I'm just going to call that good. But what I needed you to see from this example is the factoring out process. That if the inside of the absolute value is complicated, factor out of it, okay? But here is what that is going to end up looking like. Now, our last exercise is going to be, can we look at one of these and determine what the equation is? So, just like when we were graphing from an equation, the first thing I'm going to identify is what is my vertex. So I need to identify my vertex on the graph. And I need to look to see what happened to it. So first, it looks like I shifted 3 to the left. All right? So remember, left is positive in terms of x movement. So that's going to give me an x plus 3 inside my absolute value. And now, the other motion, it went up 1, 2, 3, 4, 5, 6, 7. So we have a vertical shift 7 up. All right, so there's my first step. Using my vertex, which is negative 3, 7, in order to construct backwards the equation. Now, what I also want to do, after I find that vertex, I need to find the slope of my line, okay? Because by using that slope, I'm going to be able to figure out what the vertical stretch is. So, with this being my vertex, I need to find another point that is nicely labeled on the grid. Now, this point looks like it's also exactly on the grid. So that's what I'm going to use to find the slope of my line. So my slope, I'm going down 4, and over 3. So rise over run, that means I have a slope of -4/3. Now, I'm hoping you've also picked up on that negative makes sense. Okay, whenever that number was positive, or there's just no number there, my absolute value opened up. Whenever it's negative, my absolute value has been opening down. So, and you remember the same behavior with parabolas. So I'm hoping that it makes sense to you. Then we know we must be looking for a negative number there. Now to finish off actually making this a legitimate equation, I need to put y equals, and now we're done. So again, just to recap for you that example, the first thing you do, find the vertex, and what that lets you do is in the equation, it allows you to express the horizontal and vertical change. Oops, sorry, I was misspelling there. Next, find the slope, which allows you to, in the equation, express that as the vertical stretch. So that's how you go backwards in writing these things. So thank you for joining me, and make sure you have all of those notes written down. And we are now done with section 7. So make sure you have all these written and come back to class prepared to do the practice work.